Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Takrir Sirhan, and I am one of the group member that was being assigned the topics of reinforcement learning by our beloved Madam Fauzan Toha. And my metric number is 1129839.
Hi, I am Muhammad Sajid bin Masnaid, metric number 1116259.
Hi, my name is Muhammad Ikram. My metric number is 1121909.
Hi, my name is Muhammad Hafizuddin bin Jasmi, metric number 1123623.
Panyu, what are you doing?
Come see for yourself.
Come see for yourself.
Can you walk? Okay, can you
Subhanallah, next video. The baby with zero knowledge can learn to walk by themselves. Do you ever wonder if we as an engineer can create a machine that learning by itself?
Easy. Reinforcement learning. My fellow brother, when I say that reinforcement is very easy, it is because previously I've been studying the intelligence system, which is one of the branches of the system only itself. And so, as far as I can remember, is that I did came across with example of how you train a dog. A dog, as you are all very all aware that it has a very low IQ level. But then, do you have ever came across a video whereby a master trained a dog to fetch things from a distance and also train the dogs to jump various kind of obstacles, various kind of constraints. Okay, how do you have ever wondered how did they do that? Okay, this is the concept of reinforcement that is being applied. As back to the previous example that I mentioned about the dog. Okay, when the dog does something very good, you might be praising it, or you might be rewarding the dog with food, with bones. Okay, so this dog will basically act as an agent. Okay, and the reward, and the bones and the food will be the rewards. Okay, and also, and on the other case, if the dog may do the otherwise, may not following what you have thought in, you might have to scold the dogs. So that is called as the negative rewards, the opposite of the positive rewards just now. Okay, back to the basics understandings of the reinforcement learning. Reinforcement learning is the same as a cue learning, whereby a process of learning whereby you don't need any model to develop the outputs, but you would rather be applying the techniques of try first and experiencing the consequences, and then you're going to develop an experience from that, from decisions or the actions you made. So for every consequences of your actions, you might either get a reward, a positive reward, or a negative reward. So how can we implement this concept to develop a robot? I mean, like a robot that mimics the real life of humans. The concepts again are very simple. Whenever the robot itself encountering a new experience from the consequences that he had, and then we might say that the robot has learned itself. Okay. What does matter the most is not the instantaneous reward that we're seeking of, but we would rather be seeking for the average rewards over time. Okay, let's say when the robot moved to the right, it managed to get a high reward as an output. Now, the robots actually possess a clear understanding that it should move to the right rather than to the left directions. Okay, but warning, but please do take my warning that it takes about a few million try, or in this case, which we refer this try as number of steps. The more the number of steps, it will ensure that the system will be improved better and better, which may increase the accuracy also.
Oh.
But hey, wait. Actually, the reinforcement learning is under the umbrella of the unsupervised learning.
Oh, unsupervised learning?
Yes.
What is the difference between unsupervised and supervised learning?
Actually, what is the difference between unsupervised and supervised learning? So, RL or reinforcement learning is categorized under unsupervised learning. The first thing I will explain is about supervised learning. Supervised learning is a system, a learning where we give the input to the agent or the machine. For example, we have a basket of fruit. There are 4 types of fruit in that basket, which is green apple, grape, strawberry, and cherry. In this supervised learning, we can rearrange the fruit from its color or the size. We have to measure it so that we can input to the machine, and the machine will know which one is green apple, which one is grape, which one is strawberry and cherry. So what the unsupervised learning is, we didn't give any input at the agent. The agent will decide in itself which one is our goal the first thing that it will recognize is the color of the fruit. It will categorize the color first, which is the wet and the green. The wet side is strawberry and cherry, and the green side is grape and green apple. To detect between which fruit is apple, which fruit is grape, you have to detect the size. So it will, after you detect the size, the large size is green apple, the small size is grape. About the strawberry and cherry, they are about the same size, but it will recognize the shape. Cherry shape is like a cherry, and strawberry is like a triangle shape. So that is unsupervised.
That's a very clear explanation, just on the deep value. I think I understand most of the part, but how about you?
Do you have any idea how reinforcement learning work in a mathematical perspective? You know, like equation or something?
Better ask someone or an expert to consult with the situation, just reinforcement learning. So, I think the best candidate for this case is Panjang.
Can you text him?
Yeah, sure.
Assalamualaikum guys. Sorry I'm late. I'm busy doing with my FYP.
So, you study about the mathematical equation of the reinforcement learning last night?
Yes, I have. Okay, I will show you again. I will show you. Okay, here are the general equation for the reinforcement learning. ST represents state at time step t. Reward STA is equal to immediate reward of executing action A in state ST, and represent number of steps in lifetime of agent. Reward T represent reward at time step T. E operator represent taking an expectation over all sources of randomness in the system. And finally, this general formula is the fundamental formula for any coding involved in a machine learning. Thank you.
It's very detailed explanation by our brother Akram. And then there is one thing that bothered me, about the formula just now. I think I've realized something about reward, agents, and also the state. Can any of you please explain to me what is actually meant by rewards, what is meant by agents, and what is the state? Please help me understand.
I did study about this last night. So I will explain you about the agent, reward and state, which is I found it in flowchart. Okay, I will explain about how reinforcement learning works. So in RL, we have two things that we need to know. First, the agent, and second, the environment. You can see from the flowchart here. So the agent will do the action to the environment, and then it will return the state and the reward. What is action, state, and reward? I will explain using an example. For example, I want to train a dog to jump over an obstacle. The first try, the dog will go through the obstacle and make the obstacle to fall down. So, the action of the dog is it moves through the obstacle. So, it will return two things, state and reward. First, the reward will be 1, for example, which is the low reward because the action that did by the dog is not what I want. So, the state, which is the dog go through, will return only 1 reward. then the dog will try again by moving under the obstacle, which will not make the obstacle to fall down. But still, I do not want the dog to move under the obstacle. I want it to jump. So let's say I give a reward like 2. So for the state, if the dog moves under the obstacle, the reward is only 2, which is still not satisfy myself. So the dog will try again. For this time, the dog will jump on the obstacle, which is what I want. So I will give the reward 100. So the dog will learn that it needs to jump the obstacle to gain the highest reward. So that's how the dog learning what I want, which is I want it to jump on the obstacle. The second example is how a robot can ride a bicycle. You see, to ride a bicycle, a robot need to do a balancing so that the bicycle will not fall down. So the action is when the bicycle fall to the left side, the robot will turn the handle to the right side to counter and balancing the bicycle. And if the bicycle fall to the right side, and then the robot will counter by turning the handle to the left side. So the action is the robot turning the handle, which is one is the left side and the right side, and another one is at the left side. So each action will return a reward. So if the robot happens to balance to counter the position of the bicycle, the reward will be approximately maximum. And if the bicycle fall down, then the robot will get less reward, such as maybe 0 reward or negative reward. So that is how this flowchart works.
Nice explanation by our brother with the example. Right, but I'm interested in one of the example, which is bicycle, the balancing of bicycle. So how can that example we implement it in the MATLAB so we can see how it simulates?
Okay, as we can see, in order to play this demo, we must first type the B demo and followed by the max iter, which is the maximum number of iterations, and followed by the max episode. The max iteration will represent the number of agents to take the average from, whereas the maximum episode will be represented by the maximum number of the episodes needed to run. Okay, this is the first part, as you can observe in the screen. This is the initialization part, where you have to allocate the memory place for the x-axis and the y-axis data, and then followed by the number of the declaration for the number of states and actions. Once we enter the desired number of maximum iterations, which means the number of agents, and then followed by the number of the episodes, and then the next procedure is we're gonna be gather these random single agents, which result to compare with the average, and then followed by the clear unnecessary data. We'll turn the value into a random number, and then below this function is the formula in order to calculate the average of the maximum number of the iterations. And finally, in order to make our output clearer for you to understand the principle of how we trained our data, for the bicycle to be able to be driving forward, in order to be riding forward without toppling down, we're gonna be plotting a graph which is represented by the x-axis and the y-axis. The x-axis will represent the steps, number of steps, and the y-axis will represent the number of episodes.
This graph will basically represent the average after the iterations. Now I'm gonna demonstrate how to simulate the result. Okay. For this case, we have select 1 to be the number of the agent. It could be more than 1, and the number of maximum for the episode we have chosen to be as big as we can, but here in this case we try to make it simpler with choosing about this value. So now we just press enter, and we're gonna be waiting for a figure to be appear, and there it is. Okay, from this simulation you can observe a bicycle. Okay, a bicycle is being riding. Okay, here in this simulation, observe on the screen, we can see that the stability of that bicycle changes from time to time. Okay, here you can see the stability has almost reaches its peak, but okay, observe. Okay, the bicycle suddenly toppling down again. It means that we managed to improve the stability of our bicycle from time to time, and hence it requires a greater number of episodes, meaning that we have to set the number of iteration to be it could be about millions and above, because the accuracy is directly proportional to the number of episodes. Now we may observe the real-time plot of the graph. Okay, now we may observe the real-time plot of the graph, which is the number of steps versus the number of episodes that we have been set before.
Okay, actually there is one thing that bothered me a lot, brother. I mean, despite all this explanation, all this theoretical, all this formula explained by my fellow brothers, I did understand those calculations and theoretical parts, but we need to think from another perspective. To considering that we are IUM graduates, why not? I've been always wonder about how does we're gonna be related this reinforcement learning with the Islamic principles.
Oh, Brother Tak Chris, do you mean the Islamic value that is relies on is reinforcement learning? That I know. Bismillahirrahmanirrahim. Now for the Islamic perspective, here is Surah An-Nisa verse 122. The meaning is, and whoever does righteous good deeds is a true believer. Such will enter paradise, and not the least injustice, even to the size of a speck on the back of a dead stone, will be done to them. Okay, from this ayah, you can understand if we do good, we will get a reward known as pahala. And from this ayah, we can conclude that if we do good, we get pahala. If we do bad, we will get dosa. Same with reinforcement learning. If we do good, we will give reward to that system, and vice versa. That's all. Thank you.